Good morning, sir. I am Ishwan from third year CSC. Today, my topic is about India's opportunity in the global quantum race. Now, we will discuss the topic. First, introduction. Here, in the introduction, we will discuss about the overview of the quantum computing and its global importance. First, beyond the classical bits. Here, the classical bit means zeros and ones. Unlike classical computer, which uses zeros and ones. Quantum computers uses qubits. Qubits can exist in the state of 0, 1 or both simultaneously. That is the superposition. Exponential power. They can be linked entangled, allowing them to solve complex problems that are impossible for today's supercomputers. Global importance. Quantum tech will redefine the cryptography, drug discovery, material science, artificial intelligence, and national security. Cryptography. Cryptography means breaking the current encryption and creating unbreakable codes. Drug discovery. Simultaneing the complex molecules for new medicines. Material science. Designing the new materials, batteries, and catalysts. Artificial intelligence. Artificial intelligence is accelerating machine learning algorithms. National security. A strategic advantage for any nation in the world. Global quantum race. Here the competitive landscape here the countries that are United States, China, European Union and India. United States leads to heavy investment from Google, IBM, Microsoft and Amazon. Policy is the main National Quantum Initiative Act that is significant federal funding. Focus on the full stack development and cloud access that is IBM Q network. China lead to massive state-backed investment demonstrated quantum supremacy. Policy, a key pillar for Made in China 2025 plan, focuses on the quantum communication, misuse satellite, sensing and computing. European nation leads to collaborative approach through the Quantum Flagship Program. Funding is dollars billions plus initiative focused on the building a pan-European quantum ecosystem. India, a determined strategic and slight late but promising success. India's educational landscape that is building the talent pipelines across the quantum systems. Premier institutes in the IITs that is Bombay, Madras, Delhi, etc. and IIScs are the pioneers offering specialized courses that are MTech or PhD programs and foundational researches. Online learnings that platforms like NPTEL and Swayam offers accessible quantum computing courses, democratizing knowledge. Community building. Indian research landscapes. That is the core of innovation. This slide discusses the core of innovation in the India. That are NQM, that is National Quantum Machine. Here they are invested 1,000 crore flagship mission to accelerate R&D over 2023 to 2031. Major research hubs that are IISc Bangalore, Raman Search Institute RRI, EIFR and IITS. IISc Bangalore leading research in the quantum algorithms, photonics and materials. Raman Research Institute that is RRI, the cornerstone for the quantum communication and optics searches. AIFR, strong focus on quantum foundation, superconductivity and the hardware. IITS deserves diverse research in the quantum algorithm, cryptography and hardware. That is, hardware means spin, qubits or photonics. Focus areas are developing intermediate scale quantum computer based on QKD, quantum key distribution, and magnetic meters and new materials. Industry and startup ecosystem from lab to market. Homegrown startup that is UNU Labs, Bison Desai, Vacuum Labs. Focus on the quantum safety cryptography that is QKD and PQC, India's first quantum tech company. Bison Psi that is BQP Psi, developing quantum-powered stimulation software for engineering and biotech. Quackbit Labs, working on the quantum random number generates QRNGs and security solutions. Corporate R&D, Tech Mahindra, Tata Consultancy, and Infosys have research groups exploring quantum algorithm and the software for their clients. Government initiative, the strategic push. The government has a budget base pushed on that is 1,000 crores, that is approx dollar 730 million for 2023 to 31 for this period of time. Key goals is to develop the intermediate scale of quantum computer with 52,000 physical qubits within 8 years, establish secure quantum communication over 2,000 kilometers between the cities, and design a synthesis quantum materials like superconductors, develop develop highly sensitive magnetometers for the atomic clocks and sensors, set up thematic hubs that are T-hubs in leading institutions for focused R&D. Vision of these government initiatives are to make India in fortunate in quantum technologies and the quantum applications. Strategic advantages. India unique edge. Vast talent pool, cost efficiency, strong IT and software base, growing digital infrastructure, demographic divide. Here the challenges faced that are hurdles to overcome. The hardware gap, brain drain, fragmented R&D, funding scale, standardization and policy. Brain drain. The top talent over often moves abroad and advance the researches and lucrate the opportunities. The hardware gap. Significant lag in the building of fault tolerant large scale quantum hardware compared to the US and China. Funding scale. While NQM is a great start, the global leaders are investing an order of magnitude more. Fragmented R&D. Need for stronger industry academy collaboration to translate research into the products. Global collaborations and the opportunities. QUAD Alliance, that is USA, India, Japan, Australia. The collaboration on critical technologies and including quantum. Bilateral ties with the US, IUSSTF, Japan and Israel for joint R&D projects. Partnership with the EU, European Union. Potential collaboration under the EU quantum flagships for research exchange. Opportunity. India can position itself as a strategic and reliable partner in the global quantum supply chain, especially in the software talent and niche hardware components. Future activity. The route ahead. The road ahead. Near term is 2 to 4 years. Mid term is 5 to 8 years. Long term vision. First, near term. Consolidate NQM, establish T-hubs, grow the startup ecosystems, and build a robust quantum-fluent workshop. Mid-term, deploy metropolitan QKD networks and become a global hub for the quantum software devices at our services. Long-term vision, choose self-reliance in the critical quantum technologies and became one of the top three leaders in the quantum communication and specific software domains. Here, the conclusion is seizing the quantum opportunities. The opportunities are the global quantum race is accelerating, and India has entered with a clear strategy to build the quantum computers. The combination of the national quantum machines, a strong talent base, and emerging startup ecosystems provides a solid foundation. Success hinges on sustained funding, preventing brain drain, fostering deep industry academy links, and strategic international collaboration. India may not be the first, but it has all the ingredients to be a significant and influential player, shaping the future of the quantum technologies. The final message is the quantum future is being written now. India is just a participant, but help it to help other to it. Thank, thank you.